Hello, my name is Rogelio Arcadio Fernández. I'm a third grade middle school student here at Colegios Sinaloa AC in Culiacán, Sinaloa, Mexico. I'm participating in the Innovation Award category at ICIA 2026. This project was born from a simple but powerful question. Is it possible to produce food without contaminating the water, degrading the soils, or losing the pollinators our food system depends on?
Today, modern agriculture faces one of the greatest environmental challenges of our time. Globally, more than 1.7 billion people live in regions where aquifers are overexploited or contaminated, while 3.6 billion people experience water scarcity. Problem defining. As a result, intensive agriculture can generate three interconnected environmental impacts: soil degradation, groundwater contamination, and biodiversity loss, including pollinators. Culiacán, Sinaloa is one of the most important agricultural regions of Mexico, so this issue is especially relevant. The region produces more than 1.6 million tons of food each year, but relies heavily on chemical fertilizers and groundwater resources. Inventing process. To address this challenge, I developed a nature-based solution using mountain microorganisms as a biofertilizers. Mountain microorganisms are natural microbial consortia capable of restoring soil biological activity and improving nutrient cycling. The biofertilizer was produced by collecting microorganisms from forest soil, mixing them with wheat bran and molasses, and allowing the mixture to ferment under anaerobic conditions for 30 days. Realistic solution results. To validate this solution, I conducted three different levels of scientific validation. First, the biofertilizer was applied to an experimental garlic crop, comparing an agroecological treatment with a conventional control. Second, I created two pollinator gardens with Lantana camara, where the biofertilized garden attracted 256% more butterflies in only 21 days. Finally, I designed an experimental dosimeter to analyze nitrate leaching and evaluate the protection of groundwater.
Now, in the results of each experimental validation, in the first one, the soil validation, I can conclude that by applying the microbial consortium, we can have a greater productivity, enhance the radicular development, and increase the microbiological activity of the soil. Now, in the second pollinator's garden, there was an abundance of 414 butterflies, with a difference in the biofertilized garden of 2,056%. Now, in the hydrological validation, the preliminary results show that by applying the microbial consortia compared with a chemical treatment, we can reduce the electrical conductivity and the leaching of nutrients to the aquifers. This project is aligned with the Sustainable Development Goals of the Agenda 2030, which are zero hunger, clean water and sanitation, responsible consumption and production, climate action, and life on land. In conclusion, by restoring the microscopical life of the soil, we can protect the water we drink, the food we produce, and the pollinators that sustain our ecosystem. Thanks for your attention.